Hello everyone, today we're talking about Arithmetic Sequences, section 10.2 in our book. So the arithmetic sequence formula, this is going to be given to you on the final exam on the reference sheet, but we need to know exactly what each term in our formula means. So a sub n, and we learned this in the previous section, is what term we are currently on or looking for. A sub 1, obviously the first term in our arithmetic sequence. N, again, we're plugging in the term that we're on. And then D is the common difference. What is each term differing by? What are we adding or subtracting to each term? And that's what we mean by arithmetic sequence, is we're either adding a number every time or we're subtracting a number every time. So we're not going to be multiplying or dividing. Strictly sequences that involve adding and subtracting are arithmetic sequences. So first they want us to find the nth term of this arithmetic sequence and then find the 10th term. So the nth term means I'm just going to leave it in terms of a sub n. I don't know what term I'm looking for, but if I put it in the nth term, then you just tell me what term I want and I can tell you right away. So a sub n, they're telling me a equals -6. A, meaning my first term, is -6. Okay, plus, I don't know what term I'm looking for. So n minus 1, but I do know my common difference is 3. So now I want to go ahead and simplify as much as possible. So that's a -6. That's a funky looking 6. Okay, and then one more step, simplify just a little bit as possible. I can say that's equal to 3n minus 9. Okay, so that is my nth term. So this is our nth term. So you tell me what term you want me to find. I can plug it in real quick and tell you. So here they want us to find the 10th term. So that means I'm going to look for a sub 10. So this meaning the 10th term, that's our notation for the 10th term. So that's a, the best a I can make, I guess, a sub 10, 3 times, then I plug a 10 in for the 10th term. So a sub 10 is equal to 30 minus 9, so my 10th term is equal to 21. Okay, so we found the nth term in our sequence, meaning just the general term. And then when they wanted me to find the 10th term, all I did was plug in 10 for n in both locations, give me the 10th term. Plugging in 10 for n, I see that the 10th term is actually the number 21. Now they want me to find the first 5 terms of this sequence, determine if it's arithmetic. If it is, find the common difference, and then find the nth term. Okay, so first 5 terms. So a sub 1, okay, is equal to 1 plus 1/2. Okay, so my a sub 1 is equal to 1.5. Or if I wanted to put it in fraction form, 3/2. Right? So if I got a common denominator, added them, I get 3/2. That's my first term. My second term is equal to 1 plus 2/2, which gives me, I'm going to keep it in the same kind of format, so that would be 4/2, right? It would simplify to 2, but since the first one was a fraction, I'm going to try to keep them as a fraction so I can kind of see what's happening each step of the way. The third term, I take 1 plus, well now my third term, I plug a 3 in for n, 3/2, and so that equals 1 plus 3/2 is 5/2, so we can see with the pattern here. But they want me to do the first 5 terms. So a sub 4, 1 plus 4/2. That's really 1 plus 2, but I'm going to keep the sequence going. So that's 6/2, and then a sub 5, 1 plus 5/2 is 7/2. Okay, so we can see what's happening each time, right? It's like we're just adding 1/2 more. So I can say my general term, my a sub n, is equal to my first term, right? That's what goes in a sub 1. My first term was 3/2. I add that to n minus 1, and my common difference 1/2. So I'm adding 1/2 each time, right, to get from 3/2, because my terms really start here. To get from 3/2 to 4/2, I'm adding 1/2, adding 1/2, adding 1/2. So that's my common difference. That's what I'm adding each time. That goes in for my D of my arithmetic sequence formula that we learned in the previous slide. So I'm going to go ahead and simplify just a little bit, saying my nth term is equal to 3/2 plus plus 1/2 n minus 1/2. So altogether, I see that my nth term is 1/2 n plus 1. So if I combine 3/2 and 1/2, I'm just going to get 1. Okay, so that's my nth term, and I believe that's all they wanted us to do is find the nth term once we've realized it is an arithmetic sequence. Okay, so nth term and our first 5 terms. Now determine the common difference, then find the 5th term and the nth term followed by the 100th term. So we really have 4 parts to this question. First, the common difference. How are we getting from the first term to the second term to the third term? Well, I'm subtracting 3. Okay, so my common difference is -3 because I'm subtracting 3 each time. So now I've already found my common difference. Now I want to find the 5th term. Okay, so it should be easy to see that the 5th term, a sub 1, a sub 2, a sub 3, a sub 4. Okay, so the 5th term, we would just subtract 1 more, so we should see that a sub 5 is -1. Now, next, they want us to find the nth term. Okay, so remember, a sub n equals our first term was 11 plus n minus 1 times -3. So n minus 1 meaning whatever term we're on times the common difference. So now I'm going to simplify my nth term, 11 plus -3n plus 3. So my nth term should be equal to -3n plus 14. Okay, that's my nth term. So you tell me whatever term you want me to find. I can find it just by plugging that number into n. And then finally, they want us to find the 100th term. So to find the 100th term, I will type in a 100 because I'm plugging in 100 for the term. So my 100th term, right, a sub 100 is equal to -3 times 100 plus 14. Okay, so we know that this is equal to then -300 plus 14, which is equal to -286. Okay, so we found our common difference of our sequence. We knew our first term of our sequence, so we could plug that in to the sequence formula that we learned in the first slide, right? My common difference, or my first term and my common difference. Those are really the only 2 things you need to know in order to use the formula. So I plug those in, simplified, and now it's real easy to find whatever term they want me to find, even if I go all the way out to the 100th term. So a whole lot easier to get way out to the 100th term than to keep subtracting 3 each time that the sequence would. Okay, next part of this section is partial sum formula. So we talked about partial sums in 10.1, right? But as you saw, as we got down to like the 6th partial sum, it was a pain in the butt to get all the way to the 6th partial sum because we had to have the first 6 terms, then we had to add up those first 6 terms, and then there were fractions sometimes, so we had to find a common denominator. So it's very difficult to find a partial sum without using the partial sum formula. So again, they will give you this this formula on the final, and basically what the partial sum is saying is So whatever partial sum you're looking for, you just need the first term, and then you need whatever term number they were looking for. So if, for instance, if they're looking for the fifth partial sum, you plug a 5 in for n, you find a sub 5, you'll know a sub 1, and it'll tell you the sum for that fifth term. So it saves you a lot of time, especially if you think back to 10.1 doing those partial sums. So, they want me to find the partial sum of the arithmetic sequence that satisfies these conditions. Okay, so A meaning my first term. Okay, so again, Sn equals n over 2 times a sub 1, my first term, plus a sub n. Okay? So, first thing I need to do in order to use this equation is I need to know a sub n, right? I need to know the eighth term in order to use the partial sum. So I need to solve for a sub n first for the eighth term. So that's what I'll do first. So I'll do that separately. Let me actually take this, and I'll plug in after I find my eighth term. So I need to find a sub n first. And remember, we think back, a sub n was just our arithmetic sequence formula. So I'm just doing this formula first. So I'm just doing that formula first, then plugging that into my partial sum. Still, a little bit of work, but still way easier than finding all those separate terms, as I'm sure you agree. So, a sub n is equal to, my first term is 100, plus n minus 1 times my common difference, negative 5. Okay, and I know the term I'm looking for is the eighth term, so I plug that in. I'm looking for the eighth term. Okay, and simplify, the eighth term is equal to 100 plus 8 minus 1 is 7 times negative 5 is negative 35, meaning my eighth term is going to be 65. Now that I know my eighth term, now I can go ahead and use that partial sum formula. Okay, so I know I'm looking for the eighth partial sum, right? Because they're telling me my n equals 8. So I'm looking for the partial sum of A1 all the way through A8, right? And so if you think back, that would take a lot of time doing it by hand, doing each term. So this saves us a lot of time. I plug in my 8 for n. I know my first term was 100. They gave that to me. And I found that my eighth term was 65. Okay, so I go ahead and see that my eighth partial sum is going to be 4 times 165. So my, not even sure what I was doing there. My eighth partial sum is equal to 660. See, it's a lot of time rather than going and finding the first 8 terms, then adding up those first 8 terms, which is the partial sums would be. Okay, so partial sums, a whole lot easier doing this way. Again, find the partial sum of this arithmetic sequence. Well, they've given us the partial sum, they want us to find the sum of all of this. So, we're going to have to use our partial sum equation. So we know we know our first term. We know our last term. Right? They told us the last term. They told us the first term. We know our common difference. Well, how am I getting from negative 3 to negative 3 halves? And then from negative 3 halves to 0? Well, I'm adding 3 halves, or I'm adding 1.5. So I know my common difference is 3 halves. So what I have to do now is I have to figure out how many terms, right? Because that's what I really need to know. They just told me this partial sum. They haven't told me how many terms there are to get from negative 3 to 30. Now, I could do it by hand and count all the way through, but this is still a small partial sum. Maybe they went all the way up to hundreds, right? You wouldn't want to do that by hand. So, what I need to do is I need to use, again, my first arithmetic sequence formula. So I know, let me write the arithmetic sequence formula down again. So I'm going to use this formula to see how many terms I have in the sum, and then I can go ahead and solve for the sum. So my a sub n, they told me was 30. That's the last term in my sequence, right? That's what a sub n represents, the last term, the nth term. A sub 1 was negative 3. I don't know how many terms I had, so I have to hold off on the n. That's really what I'm solving for. And my common difference was 3/2. So basically, I just have to do a little bit of algebra until I get n by itself. So the first thing I'm going to do, add 3 to the other side, distribute my 3/2. That's 3/2 n. Subtract. Actually, I'm going to have to add 3/2, so I get 34.5 equal to 3/2 n. And then I would obviously just divide by 3/2 or multiply by 2, then divide by 3. Either way, we should see here that n equals 23. So what that 23 means is there are 23 terms that get me from negative 3 to 30. So if I had tried to done this by hand and find the sum of all of my partial sums here, right, that would take me a very long time to first of all determine what are each of these terms in between, and then I would have had to add up all 23 terms. So instead of that, let's find my partial sum. So S23, I know that it's 23 because there are 23 terms, which I just solved for. So then I plug a 23 in for n. I know my first term was negative 3. I know my last term was 30. So I can go ahead and see that my partial sum is going to be 11.5 times 27. And so if I added up all 23 of those terms, if I add up all the numbers from negative 3 to 30, where I'm adding increments of 3/2, I would get 310. So that would take a long time to do by hand, finding all those terms, then adding them up. This is a whole lot easier, we can see, to get that partial sum just by finding how many terms there were and then plugging in our first and last term. Finally, we have an amphitheater with 50 rows of seats. With 50 rows of seats, with 30 seats in the front row, and 32 seats in the second row, 34 seats in the third row, and so on. Okay. So, we know a couple things here. We know our first term. We know our a sub 1. We know our a is 30 seats, right? Because we started with 30 seats in the front row of the amphitheater. We also know our common difference is 2. I'm adding 2 seats each row I go further back. And then I also know I have 50 terms. So really what I would have to do without the partial sum is I would have to go and I have to see how many seats there are in each row, all the way from 30 all the way to 50 rows back, then add each one up. But we have learned the process where first all I need to do is figure out how many seats there are in the nth row, so in the 50th row, then I can plug that into my partial sums formula. So a sub n, again, equals a sub 1 plus n minus 1 times d. So I'm just writing the formula down one more time, so hopefully we remember it, even though it will be on the formula sheet, but we should be really familiar with using it. Lots of questions have pertained to this type of material. So a sub n means a sub 50, a sub 1 is 30. Okay, I know I have 50 rows of seats. I don't know how many there are in the last row. That's what I'm looking for. And my common difference is 2. Okay, so I can see my 50th row of seats. My 50th term is 30 plus 49 times 2. And so I can see that the back of the amphitheater is going to have 128 seats. Cool. So now I know how many seats there are in the first row. Now I know how many seats there are in the last row. I know how many rows there are. So I can find, really what I'm looking for is a partial sum, so I can find the total number of seats. So I know the partial sum is equal to n over 2 times a sub 1 plus a sub n. Okay, so I just plug in what I know. I'm really looking for s sub 50, right? I'm looking for the sum of all 50 rows of seats. So I plug 50 in for n. I know my first row had 30 seats. I know my last row had 128 seats. So I take s sub 50 equal to 25 times 158, and I'll see that there are 3,950 seats in that amphitheater. So really what they wanted was a partial sum. They didn't come right out and say it, but we needed to sum up all the seats, right? Total, add them all up. So we had to know to use a partial sum. Okay, so go ahead, look at the example problems that accompany this in the PowerPoint, give them your best shot, and we'll go over them in class tomorrow.